Welcome back everybody. I'm getting ready to make the pistons and the whole thing out of metal. I thought I'd start with the pistons, but over this distance here, this end is 11.8, this end here is 11.65, so I can't make the whole bunch of pistons in one go. I'm going to have to make a piston at a time, which is going to be a bit slower, but it's going to be a lot more accurate, because if I use that section of the piston, it's going to fit in there like a sloppy ass fit. It's just a bit of mild steel I found, crusty thing laying around. I'm going to make the pistons 10mm. The ones in there are 8, so I'm going to increase it slightly, not much. Okay, I've got the 5 pistons half done. I got to cut that groove out of them and drill the pinion hole, but I can't do that until I finish all the other machining, because it takes a while to set up the milling attachment. So the next task is to make the bores to suit the pistons. The first cylinder bore is done. Oh, yeah, it should pop out. It was popping in and out with the compression of the air just then, so it's quite tight. That's the first time I've used a boring bar. I used the old trick of sticky tape to get the depth. I put a drill in, 9mm drill to 30, and that's at 20. I'm slightly making the cylinder slightly smaller than it needs to be, because I held it up into the sunlight, and it comes down to about, oh, come on, focus. The piston's at about 3 fins away from the top, so I can sort of chop off a couple of mil there, and I can use these screws because they're not quite long enough for this version. They only just bite in to the plastic, like about 1.5 mil in, so I had to glue them. So that should actually work out quite well. But there's some discrepancies in the piston sizes. I also marked the center line for them, where I'm going to have to put the groove for the con rod. We're within, like, this is 1/100th of a millimeter micrometer. Like within 1 plus or minus on sizes each thing, which probably will be good, but I'll that would be cylinder number 1. I've marked the inside of that piston with a number, so I'll design the cylinders per piston and fit them that way, since I don't have much experience in machining, so I'll have to do. So I got it out with a magnet, so it pops back out now. So I think that will make a good seal. Okay, the original tool holder for the lathe is over here. That was just crappy old standard square block thing. Then I bought this aluminium one, which the parting tools fitted in here okay, and you could adjust them to center, but it was not rigid enough. This one here is really good. It's a quick change one. Just pull the lever and it locks. But for the parting tool, to get it near center, I have to grind it, which isn't a problem really, I guess. But I'm really impressed with these tools. The holders are really good and make machining much faster than this one. This was a bit annoying because the height adjuster was only just touching. These ones have slightly larger ones. Much better. Made a little in seat which sits into the block. So the conrod's this end, and I just gotta make similar sort of little reduction at the top so the cylinder head can sit on it and be placed in center, and then part it off, and that will be the first cylinder. I'm not going to worry about putting little fins on it. I don't think it'll be needed for now. We can always go back if it overheats, but it probably won't overheat and probably won't even run properly. So we'll leave it as that. I got a couple of months before winter, so I'm hoping to have that done so I can set up the steam boiler and give it a run. Plus, got to make a generator for it as well. Okay, I'm opening up the balls 1/100th of a millimeter larger than the piston itself. So hopefully that's not too much. We'll find out. Well, that's the 5 pistons and cylinders made. They're not 100% perfect, but the little mini lathe, it moves around a bit, eh? I'm gonna have to work on this. That moves up and down. I didn't make this part properly. Oh, that'll do there, I hope. Okay, getting ready to make the cylinder heads now. I've got some 25 by 25 by 12. I got it in a 4-jaw chuck. Gonna have to take it off till that mark. Try that mark right there. So a couple of mil there, a little bit more out there because it's off centered a bit, but it will be centered after that. Hopefully I can maintain it parallel. I've got some parallel bars and a bit of magnet to hold it onto the chuck when I set it back up again. It's pretty much on center. So this will be my first time using a 4-jaw chuck, so it might take a while to get used to using it. Okay, going to take it slowly for first run. I'm pretty sure that's close enough. Could probably go a little bit more. It's a bit wonky. Focus. But probably doesn't really matter because it's only an outer edge. Nothing really happens out there. I checked it with the dividers. I had to take off another 9/100ths of a millimetre on it, and that's pretty good. So if I keep it set to the divider's distance, probably still a little touch over, but good enough. I'll keep it like that. So just another 4 sides on this one. So it's 22 point, come on, zoom in, 0.5 on this end. And it's 22.45. Probably good enough. Just it's only it's not dimensionally correct. Doesn't matter. For balancing it might though. For weight, but we can always balance it by drilling out parts of the thing. Try it. I got to take that much off there now. I was just checking to see if it was parallel. So it's set up pretty good actually, considering I could only barely fit the parallel bars in. If you look very carefully, you can see the line where you need to cut to. Okay, checking. One end's 28. Oh, no. 20.8. And the other end is slightly smaller. Is it 6.5? 6? Or 5? 5? Well, it looks like 6. So, not too bad. Tricky part's going to get them perpendicular to each other. Now, somehow, I can only put a thing here, parallels. See how we go. Working on the cylinder heads today. I have to face the front of it off and make that 1mm recess in there to suit the top of the piston flange thing. I'm setting it up like this. It's going very slowly. And these aren't to perfect dimensions yet, the outside of the square. I'll do that when I set up the mill. So far I've got 3 of them done. Got 2 left. Not sure if it's the right way to do it, but the boring bar is larger than 6mm because that's a 12mm insert there, or recess. and boring bar is like 8mm wide. So I'm coming in on an angle. I'll do the depth to about 4mm, and then once I've got the 1mm in the depth, I straighten this up and widen it. Make it a lot wider then to the right dimension. Not sure if that's the correct way to do it, but this doesn't really fit in there to do anything other than that, and then I won't be able to really get the edge square. I'm an amateur at machining, so bear with me. Hopefully we can do it good enough that it will actually spin and work. Okay, the next task is to make the conrod connector and the crank. This is 2-part. That needs to be threaded when it's metal. In the plastic version it was just super glued into that hole, or you can't feed it in and get everything in there because it's a fixed conrod, number 1 piston. That drives the whole mechanism. So I'm going to start with this piece. I'm going to probably just make the round part, and then I'll pin the conrod into its correct position and then weld it, braze it in there. Should be good enough. Don't think it's going to be too tricky to make something like that. I suppose you could, but this piece is going to be dangerous swinging around for an amateur. I think I'll go with the welded in option, and then maybe if that doesn't work properly, I'll try a whole piece somehow. Yeah, I don't know how that's even going to work if it's a whole piece of steel. You need a forge or a chuck. I got one. Probably offset it, have this flinging around, and machine it down, and somehow hack that bit out. You'd have to mill that out. You'd have to do the round parts first and then mill the rest, or not really sure. But for now, I'll just do the round section, and that looks simple. And we'll continue. Gonna have to use the parting disc to part off that gap in the center there. Gonna have to, it's about twice that parting blade size. Not quite, I don't think. So we've got a 4.5mm hole for the pin. I've can you see that? It might be center point for the holes already, but I might 3D print one of these, a blank cup with the holes, and just super glue it to it, and then just drill through it as a template. Be a lot easier. This is really fiddly and hard to see, so I think that will be a quicker option. It'll take like 10 minutes, and Tinkercad 5 minutes. Cutting that little groove. It's 3mm wide. This is only a 2mm parting blade. I have a 3, but I got no holder which will fit. The rigidness of the lathe is really not good. I had to tighten these up because that's as deep as I can get at the moment. I've still got 4mm to go. And see where there's a big notch in there? That's where it just crashed. It was tilting from the cross slide gibs. I had to tighten them up, so now it's really hard to feed, but I can feed. I've just been doing this for a while to clean it out because it made a big chip. Man, little mini lathes don't part off, do they? Like the videos on YouTube are saying. I'm gonna make a different tool rest. I have a big block of steel left over. That would be the project after this project. Alright, let's see if I can get it. Okay, that's the deepest I've ever parted to without it having an accident. And that's a 3mm, that fits nice. Needs a bit of clearance for the con rods to fit in there. Perfect. Didn't think I was going to get it. I'm going to hacksaw the rest of that off to make the other part. Parting is too stressful on this thing, and these are, look how hard I gotta turn this thing. Yeah, it's taking up the slack. Okay, found some new information about some nickel-ion batteries. Adding some caustic sodium increases the cell's performance. So we've had 148 charges on the cell, and we're around about 593 milliamp hours and 783 milliwatt hours. It does range, varies, and if I fill it up with too much water where the liquid actually hits those metal plates, we lose a lot of current because it's just going through those plates instead of down through the cells. So I'll make a note. At 149 I added 8 grams of sodium hydroxide. Made the whole template thing today in Tinkercad and printed it out. Made a shaft so it actually aligns. All I got to do is put a bit of super glue, hold it in position, and I can drill those out. They should be perfectly aligned. Drilling went alright. I've got 2mm holes there, and is it the other way around? 2mm holes there, and 1.5 there to be tapped for a 2mm thread. Because I'm gonna have to put a little screw in there to hold everything. The pin won't work because it might fling out. I'm doing the con rods today. One's got to be welded into place, the main con rod, but I'll still locate it from its hole and I'll pin it, and then I'll weld it across each side. Should be strong enough, and the rest are pivoting ones. So all I got to do is run the hacksaw down this way, cut them off and grind them up. I'll first drill the holes, pilot hole, so I've got the exact locations. Going to fabricate the body of the housing crankcase. I printed up a little jig which is the right size. That should help. I'll just tack it. The little peg on the top is so when the end plate goes on, I can center the pin and everything and weld it in position. Okay, it's starting to look like the crank housing. I tacked it down to this plate first. That's perfect. Pushed them all back in so they're aligned because the shrinkage of the weld will drop them out. So this thing fits in any direction. And it sits in the center of that one as well, so that's the same size. All I gotta do is tack it, break it off and give it a weld through them. Not sure if I should bolt the end plates or weld them. Probably weld it. This one's a solid piece at the back, and the front plate would be bolted, but I'm not going to bother about this one. These are 25. I'll have to either machine them down or leave it wider. Doesn't matter, I don't think. I'll see how I go. So, welding up time now. Once I tack them all in place and give it a bit of a weld up the sides, I can break the tacks off and finish it off. I squared them all up. I squared them off the top plate, off the top edges. Because it's not very straight along there or along there. It should be fine. Well, time to make the end caps for the thing. I got the main polygon, I should say. I jammed that in there. I can't get it out. See how I tried to center punch it out. So I'll leave it in there until I locate, cut and make these plates. One's going to have a hole in it. Got little 1.5mm holes on the corners. I'll just cut that out of some scrap, clean it up, glue that on there, and then I'll put the holes in the center hole on one of them. May do a little hole on the other one too so I can locate a pin, and then I'll have a center because that's where the drive end will be. This end's going to have this, fits over that. I'm making it a bit larger because I need to stick a brass bush for the crank to spin in. And that will be welded on the back of that one and then bored out. That's the first time my machining came out really good. I've got centerline scribed onto it. I'm having trouble with facing because the mini lathe needs adjusting. It's the saddle's sort of moving around on the lathe bed. Okay, got it welded up. What I'm going to do is put it on the lathe again and clean it up. Didn't need to bang this out. All I did was tack it in 4 spots, 2 on the polygon and 2 tacks on the cylinder, and the little thing shrunk and melted out. Did melt in there a bit. So it's turned to carbon after welding. You can sort of, can't see in there, it's down one edge. Yeah, see there's a black edge there. Sort of dripped out there. But I'll clean that out. It's a lot stronger being melted. Alright. Looks the part. It's pretty weighty, but most of that's going to be bored out anyway. I'll go around the outside here. I'll clean up the weld if I can get in there. Might have to hold this in the forge or truck. Do it that way. That one took a bit. I've got it in the 4-jaw chuck. I'm going to have to live with that because that took forever. I was trying to set it up on the square faces, but what I'll do is take all the measurements after I machine the shaft. Take the measurements from the shaft to the height I need, because I ground too much off on that one, so that didn't quite help me measurements putting it on here. It was all over the shaft, I couldn't get it right. But now that's sitting true. I think that will do. Drilling 11.5mm hole through it now. I'll have to bore it out to 12.5. So I'll start with 11.5, just in case it's skew with. The mini lathe works best when it's in low gear for drilling, because as soon as it detects any torque and it slows down, it tends to want to increase its speed to get the desired torque, and it gets a bit dangerous. Like, you can break your drill bits and whatever else. So I'm doing 90 RPMs, whatever you want to call that. And just going slowly, letting it do its cutting by itself. So in high range, that problem's even greater. You can accelerate up to like an extra 500. And man, that gets scary because it's doing like 2,000 RPM. Forward through. So it turns out there's a slight error in the centering to the plates of like 0.6mm, which will just make these a bit thinner when I when I go to surface these. I'll take the measurement from the shaft here upwards. I was messing around all day trying to get the thing to line up on that. As you can see, it's not very evenly placed because of the 5 flats. The weld was a bit hard to machine. Had to go very slowly. I haven't chamfered it yet. I just sort of cleaned it up a bit. So I think I might bore it out tomorrow or something when I get the chance. Okay, finished boring it out. It's slightly a bit larger. So when I machine this up for the bush, I'm going to have to be very careful. I had to put those 2 magnets there to lift the guard off of the chuck slightly. So you swap out the 4-jaw chuck now and put in the 3-jaw for this job. I took out the movement in this. Much better now. No movement. And it moves. Somehow those bolts under there became loose. All you have to do is take out the lead screw and you can get under there. Because they're tucked right under there and the lead screw's right on center of the bolts. So you can't get the Allen key in there at all, unless I chop our Allen key down, but then you don't get much movement between here and there, so pointless. So, glad that worked. That was annoying me. Probably should have did that when I first detected it, because it was playing up on the faces more than anything, because I did the sides with the auto feed, so the lead screw bolt held it in position, I guess. Very dodgy, but yeah, the whole thing's dodgy. I just got to face the inside of that off, because the crankshaft actually rests against it inside there. And there's the boring bar. Here it goes. So going by that little round machine surface there, it's just slightly out there compared to the other sides, and a bit on this edge as well. So actually we'll be within tolerance. It just means these ones here will be slightly thinner than these two. Maybe a balancing issue, but we can always drill holes around that thing to balance it. So, just got a bush to make, the crankshaft itself to make. It's going to be tricky. I got to get that cam location 25 degrees from that hole, or the hole 25 degrees from that cam, because that cam's on 90. So we'll take it that way.